when I started looking into Effect, I started seeing, well, this has a lot of promise and potential if you use it in the right way. And what I mean by that is like, you don't have to necessarily go from 0% to 100% overnight. You don't have to completely redesign the entire application to take advantage of some of the benefits that Effect has to offer. That's kind of how I started, was incrementally adopting Effect in parts of the code base. And this was really what enabled it to work at all. If I had to say, hold on, I need to take this for a month and just completely build it from scratch, and nothing's going to work, and I can't deliver any new features until I'm done, that was not going to fly. I was in a position where I did not have to ask for permission to go live in a cave for a month or however long it was going to take. I always avoid being in that situation. I don't think that's a good place for us to be in as software engineers. We need to be shipping every day, shipping features, shipping bug fixes, shipping products constantly. And we never have the luxury to just say, well, hold on, I'm just going to spend a month not shipping, to do this technical thing that I can't really explain why I have to do this, right? Nobody likes that. So fortunately, Effect is not a framework that is like that. That's not what was asked of us to adopt Effect. Instead, it was, you can start plugging in Effect judiciously here and there. And I started at the top level of the application, around the WebSocket connection layer, around the HTTP layer, and the application runtime. And that allowed us to kind of have a top level of error handling that immediately provided benefits for recovery and so on. But we didn't stop there. That was just the first step. We started kind of rebuilding different parts of the application. Some of them were isolated behind a run promise or a stream that was, emitting events into an event emitter. But it allowed us to kind of rebuild isolated parts of the application on their own where, selectively, where we thought they had the most value to be converted into Effect, and often driven by product requirements. So when I wanted to implement interruptions, that was the reason to now rebuild the speech-to-text component in Effect, because it was going to be a lot more work to do that if I was going to have to do it the old way. It was it wasn't rebuild the whole thing in Effect, the entire application, or just keep working the old way. It was really for each isolated piece. It was do I want to add more spaghetti to this application and this component? Or can I just rebuild this piece in Effect and make it much more expressive and elegant while building the feature that I'm being asked to build? So it was much less of a refactoring process and more of a incrementally adopting it while also building and delivering features.
I love that. And I think you've hit on a couple of really nice points here. One is that Effect, even though you get a lot of benefits, once you have kind of effectified more and more of your application, you're going to find that you can delete a lot of code. Everything just fits nicely together. In the same way, if you incrementally adopt React, let's say we're just in this transition of transitioning a larger code base from jQuery, something else, to React. You don't need to do that in one long night, but you can do that step by step. And once you've reached a point where everything is in React, then you can delete a whole bunch of glue code, a whole bunch of things that bridge from the old way to the new way. But it is also totally fine that you go through this transitionary phase. But the other thing that you've mentioned that I think is a super great insight, which is how do you prioritize what to refactor with Effect when, or when to rethink something and apply Effect. And this is so elegant that you can go top down from hey, what is the thing that we want to improve for users? What is the business outcome that we want to affect here? And then looking at those, Effect typically has something in store for that. If you want to improve performance, if you want to improve reliability, resilience, error handling, whatever it might be, Effect typically has something in store for that. And then you can prioritize what to work on depending on your end user needs. And hearing here about the speech to text aspect and applying effect for that, that sounds super interesting. So I want to hear a little bit more, like zooming into from macro into a bit more micro into this component. Can you give a rough overview of like how that thing was built before? What you diagnosed the biggest kind of like things to improve were, and which primitives of effect did you use to ultimately implement it?
Well, actually, what I prefer to do is zoom in on the text-to-speech component, which is...
Sorry, I remembered that wrong, but yes.
No, it's okay. You remembered it right. It was I said speech-to-text earlier, but I feel like the text-to-speech component... This is the component that I also talked about in my Effect Days talk and did a deep dive on. I feel like the text-to-speech component was kind of like a real unlock, really an aha moment of like, wow, this is what Effect can do in terms of like saving a lot of complexity, from your code base. As I mentioned, this is a component where like it's a WebSocket and we stream LLM thoughts to it. So an LLM response, as you might be familiar, it sends, what are called chunks in a chat completion response. And the chunks are usually a token or two tokens, and they're not complete words a lot of the time. So then we're like accumulating the chunks into basically what we call coherent thoughts. And those coherent thoughts can then be sent to the text-to-speech component to generate the bot audio. However, if there's an interruption, we need to shut down the LLM, and we also need to shut down the text-to-speech component so that we don't continue to generate more thoughts based on the previous thing that the user said before they continued talking, and now we want to start over and respond to the most recent thing that the user has said. So the text-to-speech component now, it's a WebSocket connection. When you send it a coherent thought, that connection will then respond asynchronously with one or more different events that you might get. And we're basically just streaming those up to the client. But when there's an interruption, we need to actually shut down the WebSocket connection, close the connection abruptly so we don't get any more messages from it, and then reopen it. And then in that period of time, and it's not usually very long, it can just be like 100 milliseconds or 200 milliseconds where we're waiting for that WebSocket connection to open. We've created a connection, but we've not yet received the open event from the connection. And it's in that time that we were often getting the LLM was trying to send messages to it, but it was erroring because we're sending WebSocket messages out to a WebSocket that was not yet open. So we had to now queue those messages to wait for the open event from the WebSocket connections and then flush the queue when it was open. So as you can imagine, this created some code complexity in the pre-effect implementation, and it was something that Effect turned out to be actually very good at, because these are the kinds of things that Effect has out of the box. In fact, we were able to replace the WebSocket handling code with the WebSocket utility from Effect's platform APIs. And that has kind of a magical property to it that you don't really ever have to think about when the WebSocket is closing and opening, and you don't have to wait for an open event. What it essentially gives you is what is called in Effect a channel. And this became a primitive that I became curious about. It's something that I wish was a little bit more first class in the Effect world. It's certainly used behind the scenes in a lot of things like Stream and other APIs in the Effect world, but this is what you get essentially when you create a WebSocket connection using the Effect Platform API. But then if you use the Effect Stream operator pipe through channel, you now have a duplex stream, which is one where you can start listening to other streams, and then instead of doing like a run for each or run collect or whatever you're doing, and that you typically do with a stream, you now are piping the events or the items in that stream out through the channel, through the WebSocket connection. And then downstream from that pipe through channel, you are getting incoming events that are coming from that WebSocket connection that you can then emit further on down your application. So this is great, but this is also what this is also doing is this is abstracting the WebSocket lifecycle into the stream lifecycle. So if you emit an error upstream, it will close the WebSocket for you. And then if you have a stream.retry, it will reopen the WebSocket for you in the event of an error. And because the streams are pull-based, you don't have to rely on queuing explicitly. You aren't going to miss any of your events. When the stream is reopened, it will start pulling those events and behaving as expected. So this really allowed us to abstract all of the sort of tangled, like we had, I think, a promise that was a reference to a promise that was kept around and was awaited in different places. And it was a mess before. And now we had a single stream that was just a linear stream where you had the stuff going in the top and the stuff coming from the stream coming out the bottom. And it became very easy to reason about what was happening. And you didn't really even have to think about the stream lifecycle at all. It was just emit an error when you want it to close and then just retry. The WebSocket connection is now handled by the stream lifecycle. So you can use the stream retry. The stream will be shut down when the scope of the stream ends, and the WebSocket will automatically close. We also have a flush event that we send out to the text-to-speech service, which essentially says, we're done sending you new speech for now, so send us everything you got. And the peculiarity of this particular service is that they will then accept your flush event, and they will promptly close the stream on you. That's not really what we wanted, but I don't know. They designed it this way, and I don't really have leverage to get them to redesign their entire API. I just have to work with what we have, right? This is a lot of application development. You don't have the liberty to redesign every API that you're working with. You have to abstract it in some way. And so this is what we're having to do here. But the effect stream primitives make it really easy.